Hello everyone, today I'm going to be talking about a useful problem solving tool you might find on your calculators, which are the inverse trig functions. And basically, the buttons on your calculator are going to look like sine minus 1, or cos minus 1, or tangent minus 1. And basically, if you are used to the fact that in function notation, f negative 1 of x denotes going backwards from fx to x, then this is kind of the same way. You're going from a sine value back to the angle it came from. And this is really quite a useful problem-solving tool. And it's important to be able to use these effectively on your calculator. And basically, you can answer questions like, in this triangle, where it's a right-angle triangle, the hypotenuse is 5, one side is 4, and one side is 3. What is, like, say you want to know this angle here. What is it? So, an example usage of this would be, first you know that the sine of this angle is going to be the opposite over the hypotenuse. So, sine theta is 3 over 5. So you're going to take the inverse sine of 3 over 5, because this will eventually lead you back to the angle theta. And it's going to be something pretty funky, like not a special angle, but just something you can find out on your calculator. But that's basically an introduction to these inverse trig functions. And one problem-solving thing that you'll need to know, definitely, is in equations where they might give you just some arbitrary equation, like 0 is less than or equal to theta is less than or equal to 720 degrees, and they want you to find sine theta is 4 over 5, solve for theta. And you'll need to know, how do you find other values of theta for which sine theta is the same, cosine theta is the same, and tangent theta is the same? Well, tangent theta is actually pretty easy, because you can just add or subtract 180, because the graph repeats itself exactly every 180 degrees. Like, if you know the tangent theta is here, and you know this angle, then it's just 180 degrees to the next one. Or plus 360 degrees. And also in the other direction, and so on. So your calculator will only give you an angle in a certain range, and you might need to extrapolate from that which other angles have the same value of sine, cosine, and tangent theta. And for sine and cosine, there's another kind of intuition. The first is one that you can learn from the graph of it. So if you have the sine wave here, and you know that this is going to be 180 degrees, this is going to be 0 degrees, this is going to be 360 degrees, you'll find out that basically a calculator will only give inverse sine answers in this magic range here, from here up all the way up to here, where this is positive 90 degrees, this is negative 90 degrees. And it's up to you to find out which other angles have the same value of sine theta, because this is the only function which is going to be reversible. So like, say if you have any x and sine negative 1x, if you plotted it the whole way up, then you'd get a repeating wave, and there'd be infinitely many answers for any kind of x you give it. But say that this is the case, and you have just this portion of the graph here, when the inverse sine of something is negative, it's gonna, like, basically the graph's gonna look like this. It's just one cut out portion of a sine wave and flipped 90 degrees because, like, flipped along this line here because we're taking the inverse of it. Anyway, so this goes from 0 to 180, and basically the key point here is that if you have a value of theta here, the gap between theta and 0 is the same as the gap on this side from theta to 180 when you're looking at a horizontal line for all of the values of theta for which sine theta is the same. And basically this leads you to the point where sine theta equals sine 180 minus theta for any theta that is in between 0 and 180. And then the same kind of logic will apply down here. So if you're dealing with a negative angle, and this is going to be like here, the angle here, the gap between here and here is going to be the same as the gap between here and here. So that also means the gap between here and 90 is going to be the same as the gap between here and 90. So say that 90 plus some number is equal to theta. That means 90 minus that number is also equal to another version of theta, which sine theta 1 is equal to sine theta 2. Or, in general, a more simplified way of putting it is that, say for any angles here, way up here, sine theta minus 180 is equal to sine 360 minus theta for this gap here. Or this might actually this might not actually be the case, but then basically use your intuition and the fact that the sine wave is symmetric along the vertical lines like 270 degrees, 90 degrees, and you sort of use that intuition to find out sine values. So say you get a question like sine theta is 1/2 and negative 180 is less than theta is less than 540. And if you put this into a calculator, it'll tell you something like theta is 30 degrees. And you'll need to extrapolate from that. So you have your hump here of the graph, and this distance is going to be 30 degrees. And then this distance here is also going to be 30 degrees at the line of a half. And this is 30 degrees from 180 on the left side, so this is obviously going to be 150 degrees. So theta could also be 150 degrees. And then you go through the hump part of the graph here to go back up to the peak again, where this line here, as it passes through 0, is going to be 360 degrees. And you know it's going to be less than 540, so we'll stop here. We know the gap between 360 and this line is going to be 30 degrees. And so this is going to be 390 degrees. And then we also know, because this was on the right side, we added 30 degrees. And since this gap is on the left side, we know this gap is 30 degrees from 540 degrees. That 510 is also going to be a valid answer. And finally, let's just check if there are actually any values for which this is the case, less than 0 and down to 180. And it turns out there's not, because there's nothing in the line of line of positive a half here. It just ends here, and there's no solutions in this area. But basically, that's how you know. That's how you extrapolate and get multiple values of theta from the same sign. And you can use the same kind of patterns for cosine. So like one notable pattern is that cosine is symmetric around the y-axis. It's a reflection of itself. And so say you know that, because I'm fairly certain the inverse cosine is given only between 0 and 180 degrees, because obviously you flip that along here and you'll get a graph sort of like, what would it be like? So say this was your x and this was your cosine -1x, and then perhaps over here when x is 1, cosine -1, x is 0, and when x is -1, cosine -1x would be 180, and then there would be this here, and overall it'd probably look something like that. So that's the graph of cosine -1x. It goes up to 180 degrees, and that's it, no more, no less. And basically, for cosine, you can use the same kind of intuition that it repeats every 360 degrees. So say you wanted to find, it gave you like 80 degrees here, and you know the gap between here and here is 80, and you know this line is 360, and so the gap between here and here is also going to be 80, and so this angle here is going to be 360 degrees minus 80 degrees, which is going to be 280 degrees. And that's how you would find values of theta for the same cosine theta. And finally, we just gonna go over tangent process again. You just add and subtract 180 degrees for tangent because it repeats itself every 180 degrees. Now, a word of advice for using these inverse trigonometric functions in real questions on the exam: if you get funky numbers, don't doubt it, because that happens a lot of the time, and they'll just want you to give your answer in 1 decimal place or something. So if you get some funky number that you are not too sure about why it's there, or why the answer would be like that, just have faith in yourself that you will probably manage to complete the previous math without mistake. Just try and make sure that you do the math without mistake first, and then you'll get a valid answer for theta if you're really trying to find it. So yeah, that's my advice for using inverse trig functions, and basically I hope you have a better understanding of what they are and how they are used, and thank you for watching.